Okay. In our previous lecture, we learned that in order to achieve a C steady state, 3.3 half-lives need to pass. Okay. This can be problematic if, let's say, we have a drug with a very, very high half-life. The way we get around this is we administer a loading dose. And a loading dose is a very, very high dose that's intended to immediately reach the desired concentration. And then it's going to decay down. So the loading dose is going to be based upon the amount steady state that you want maximum, and that's going to be equal to your loading dose. Okay, so in red, this part of the curve is going to be due to the loading dose. Each interval, what's going to happen is after decaying, the amount that's remaining is going to be equal to the loading dose times e to the negative k tau. Okay, one thing I always like to think about is that e to the negative k tau or e to the negative kt, this is going to be your fraction remaining. Okay, and if that's your fraction remaining, then the fraction lost is going to be dl times 1 minus the fraction remaining. Okay, so if the fraction remaining is e to the minus k tau, then the 1 minus e to the negative k tau is going to be equal to your fraction lost. Okay, and if we want to keep a given concentration range, okay, keep a given CSS max, keep a given CSS min, we're going to administer loading doses, or not loading doses, maintenance doses. Okay, so we need maintenance doses. The presence of these maintenance doses, what they do is they maintain the concentration that's desired. And what you have to do is you have to replenish what got lost. So it makes very logical sense that your maintenance dose is going to be equal to whatever was lost, which is loading dose times 1 minus e to the negative k tau. Okay, on your equation sheet, you're going to see this equation as loading dose equals maintenance dose divided by 1 minus e to the negative k tau. And what these maintenance doses do is they maintain your desired CSS max and CSS min. Okay, so whereas in red, that was the rapid jump in concentration, that was the loading dose, the maintenance doses, they maintain your desired concentration.